So thanks for coming along to this talk on how you can supercharge your data with Azure AI Search and OpenAI. A little bit about me first. So I'm an application architect manager at Avanade. I'm also an MVP and an MCT and a ProSite author, and I run some user groups. I'm a podcaster. I've got two little girls at home, so that's kind of why I like doing this sort of talking in the scene, to be able to spread the knowledge and make sure that people can have access to this. Now, I've not bothered writing the talk, so let's see what happens if we ask OpenAI to do that. So, write me a talk about how we can supercharge your data with Azure AI Search and Azure OpenAI. Sorry, but as an AI, I don't have that capability. Great. What about if I drag some data in about my talk? Drop that in there. Data added. All right, let's take a copy of my original question and paste that in here. Okay, you're on your own, perhaps ask Clippy. Well, geez, yeah, probably not. But, oh no, now we've resurrected Clippy. This is bad, and Clippy wants to help. No, we don't want that. No. Now we've gone back in time, and yes, PTSD is real from that. That was a bit silly. Yes, I know it was silly, but actually it illustrates a good point in that we're using public AI models here, and they are trained on public data, not our data. So this talk is really about how you can take your own data and couple it. There's a million different ways of doing this. You can almost do it with a checkbox in Azure, but you don't get flexibility when you do it that way. You only get part way there. So hopefully I'll give you some foundation for this with that. Now, being as we started out with a bit of inception, let's ask generative AI what generative AI is. And that's achieved by the use of deep learning algorithms and trained on large data sets and generate content based on patterns and rules. Again, this is the public internet, so Twitter, Stack Overflow, this is what it's been trained on, and other things that it probably shouldn't have been, but nonetheless, not your data. So just as a bit of context for those that perhaps new to that, we're talking about large language models, and these things are powering AI, chatbots, natural language understanding. Everybody's got one. So Google Gemini, Meta Llama, X, Grok. We'll be talking about OpenAI and GPT. Within them, we have categories of models that will do specific things. So GPT-4 and 4.0, for instance, for the chat and problem-solving elements. Arda embeddings, I'll come back to that, but this is to do with vectorization. And then we have DALL-E for images and Whisper for audio. I'll be using the Azure OpenAI service here and not ChatGPT, because if you're going to put your own data into there, good luck. Looking at you, Samsung. We get the same models as you would through their public services, but we also then get to layer on the best of Azure, so security and private link and virtual networks and things like that. Responsible AI is important. I know some people would argue that we're never going to get there because of reasons, but making sure that we've got those guardrails in place for folks and they don't get an answer that could be dangerous or ask a question that could be dangerous is super important. And because we're talking to Azure, we'll get multi-language SDKs. So for us, C#, but you can do this in Python, JavaScript, pretty much anything you like. And before long, we get a demo. Now, a lot of you will have seen some of this stuff, but it's important that we set a context. So, this is the landing page for the OpenAI service in the portal. There's not much there. One of the things that you will need to go get is the keys and the endpoint. I'll go to that screen, but I'm not showing you, stealing my GPT-4.0 tokens. So you can take those and embed them into your application. And then that's about all you're going to be able to do in here of any relevance for this talk before you go to Azure AI Foundry. And I'll zoom in a little bit. Who's used Azure AI Foundry? I'm imagining if you're here, a fair few of you will have done. Not as many as I would have thought, actually. Interesting. Okay. Hey, Phil. So here, again, we've got that same information sitting in front of us. So we've got the API keys and the endpoint, my subscription ID and things like that. We've also got down here at the bottom the deployments, and this is the models that I've deployed. There's some old ones in there, Da Vinci, for instance, but we're looking at the GPT-4o model down at the bottom. So this one down here. And then we're also going to be looking at this embedding model just here. And I'll keep laying little seeds about embedding, and we'll get to that in a bit, but one thing at a time. When you've finished exploring all of that, you can go to the chat. And here we can actually interact directly with the models we've deployed under these, under Foundry. And you can choose whichever one you like. So we can choose GPT-4o here, for instance. And we get a system prompt. So this is how you want that model to behave at the moment, just to be helpful. We also get some stuff down at the bottom here on how we set our model up, so how many passed messages for this particular environment, the maximum response length, temperature, so how variant that response is, top P, and so on. We won't look at that in too much detail, but we can also interact with our model here, so what is Microsoft's mission statement? Or something like that, and then we'll get a response back. So to empower every person, every organization on the planet to achieve more. But again, this thing doesn't know anything about our data. So if I say, what was XYZ retail's net income in 2021? I'm sorry, but I don't have access to specific financial data. So this is good, because otherwise something's gone badly wrong because all of your accounts have suddenly made it into ChatGPT or OpenAI. We do not want that. So that's nice, we like that. Now this, if I go to the Home tab, this is the demo app. All the source code is available on GitHub, so you'll be able to go to that later. And this is what I'll be using to illustrate some of the points that I'm talking about today. There are 3 different pages, the chat, the AI search, and the OpenAI plus search. And we're going to start in chat, which is basically a replication of what you just saw there. So again, what is Microsoft's mission statement? And if all's working, then Microsoft's mission statement is, and exactly the same thing that we saw there. So to get that to work is actually pretty simple. So I'm not going to drill through all this code, because looking at code is inherently boring, especially when it's somebody else's. But this is all done in Blazor server hybrid, so we've got a WebAssembly front end, and then the server back end. I'm imagining a fair few of you use Blazor. How many of you? Yeah, a fair few. Good. So one of the things that I've done slightly differently here, and there's a million ways to do this, and I'm not telling you this is the way you should. I don't like exposing the endpoint of OpenAI on the internet. I just don't like doing it. So what I've done is I've kept all that on the server, and I've used SignalR for that chat experience. If anyone's ever used SignalR and done a tutorial, the first thing you ever wrote was a chat app, no doubt. So that's what I've done here. And there's another couple of reasons why I used that. You could, of course, write your own streaming API endpoint or just connect direct to OpenAI. Perfectly fine. Just a bit more risk-averse in that particular scenario. So there's a bunch of Razor markup, and then our SignalR hub sitting at the top here. And then we create the hub, and then there's a couple of different ways of receiving the data. So I'm kind of mimicking how this works. So OpenAI will give you the whole response in one go, if you like. But if that's a big response, it's a terrible user experience waiting for that. So pretty much every chat app you'll see will have that nice streaming response, which is what we've got here. So we just take that token by token response and fill it into that little chat bubble, and off we go. And then to send the query, we're using SignalR again, and we just send a query, and that pops out on the other side, and then we do something with it. And we do that on the server side. So you need to configure your keys, instance name, endpoint. So that was the data that you saw there in the portal earlier. And then when we receive a query, we send that little ... out just to say, doing something. And then we include, if we want to, some previous messages. And then at that point, we can say, add those messages to a bunch of chat completions, get the options. You know, remember I showed you those parameters, temperature and that side of things. We can add them as well. And then we ask it to give us that streaming chat. So that's that same streaming endpoint that I was talking about there earlier. So that will give us a token at a time almost, or a set of tokens rather than the entire response. And then we just wait for the results. And when we get them, I'm actually putting each token in a queue. From my experience using ChatGPT, it's lumpy when you use that streaming endpoint. So you get 1 token or 17 tokens, and it looks a bit jarring. I'd far rather that teletype type response. So I stick it in a queue, and then on a timer down here, I then send each of those tokens at a nice, steady rate, which you can tune, of course, depending on how fast the data comes in. And that is the code for making the basic chat. There's not that much there, to be fair. And having the SDK really does help to make that work. So that's good. I've got many virtual desktops. So we live in a world of unstructured data, and that is things like text and images, video, audio. And all of that lot on the public internet is what they've used to train these models to make them great prediction engines. But that's all they are. They're not intelligent. They're just doing next token, next token, next token. But how do we do that with our own data? Because we don't, again, want to just go into the open ChatGPT and feed it full of data. That would be bad. We need a way to couple those two things together. So we can use something called Retrieval Augmented Generation, or RAG. And this is a way that we can bring our own data and couple it to the LLM. And what you must use when you're doing this is the original query, the original prompt from the user, and then we use that to query your database. And then we combine the results back out of the database, where all our data is, with that original prompt, and give all that then to the LLM, and the LLM will then respond based on that data, rather than what it's trained on, essentially. We can sort of see this in the portal. So if we go back here to the chat playground, on the left here I mentioned we've got a system prompt. Now if I clear this chat, I made some fictitious company details here. So if you go to the 2021 one, for instance, and zoom in, then I used OpenAI to create these random. There's also, so the normal sort of stuff you get in company accounts. So they're regular accounts, and then balance sheet highlights and executive summaries and things like that. It was actually quite fun doing that, because I've not quite understood exactly what some of these things have. But nonetheless, I did that. Now we can take a copy of all of that, Control and C, and we can say here, please use the following data to reply. Paste all that lot in, and then we just click Apply Changes, because otherwise your demo looks very silly. And then, saw earlier we asked it about XYZ. We could say, what was XYZ Retail's net income in 2021? And if everything goes according to plan, XYZ Retail's net income was 90,000. So, and I'm not making that up, because look, there it is, net income, 90,000. So now that's able to use the data that we've given it, our own data. We've not had to give that to ChatGPT to be able to do this. We're using it on the Azure OpenAI Service. This is sandbox to you. Whatever you use here doesn't get trained on into any model's data. It is sandbox to you, so safe to use at this point, which is nice. But one of the issues with this is that who wants to be copying and pasting into something like this every time? Not the way we should be doing it. And also down at the bottom right, you'll see that we've used 1,200 out of our 128,000 tokens. Might not seem too bad, but if your documents are large, and mine was not, you'll soon rack it through your tokens by giving it all of that information. Plus, it's too much context. And context is really important, as Layla's talk was talking about. So, great, but we need a better way of being able to do that. So, we can do something specific in this case. We need to ingest our data into something. Then we need to do something called chunking. Has anybody ever heard of chunking? I don't mean you've had too many beers on a night. So this is a way that we can break our data into smaller parts. Again, if your documents are huge, when you give that as context to your LLM, you're just going to run out of token space. Not good. Also, you'll flood the context with too much information. It's not specific enough. Chunking is pretty complicated. Now, some of what I'm showing you here, you can do just with a tick box in Azure. Link your own data source. It will do chunking. It will ingest it and everything. but you have no control over how it does it other than the size of the chunk, pretty much. What you'll find when you start doing this properly is that, great, we need smaller chunks because we're going to run out of context size, but now that chunk is contextless itself. It doesn't know anything about the previous chunks. So there are a load of techniques that you can use where you have a sliding window chunk, or you have a summarization that you add as metadata to each of the chunks from the previous chunks, and you won't get that. So this is going to be useful, I'm hoping, from that angle alone. We need to store this in a database. I'm going to be using Azure AI Search, and then you retrieve it using a query. Now, Azure AI Search, this is a cloud-based, they call it an information retrieval system. Isn't that a database? Maybe. But you store your documents in here, and then you can query over it. Again, it's a database. But you can query it in a few different ways: text, fuzzy searching, proximity, vector. There's that little seed again. And again, it's an Azure service, so we get access to the SDK. Now, Azure AI Search, you can imagine, is like a database, as I've just said, and an index is like a table in that database. So it's got schema and fields, and each of those fields can be filterable and facetable, meaning that you can bring down an array of those particular results in that field and use that for filtering, creating drop-down boxes, which you'll see in a bit. And then there is a variety of ways to query it. You can do a full text search, so just a regular select statement. You can do a vector search, which is a mathematical way of doing it. I'll talk about vectors shortly. You could combine these two with a hybrid search, which will improve the search result ordering. And then there's something called the semantic re-ranker, which is a paid service that sits on top of that, and that looks at the semantic meaning of your query and couples that with the other metadata fields in each of the rows, and then re-ranks the results. Really important you get those results in the right order, otherwise you can end up with faulty results. So let's have a look at that. So this is the landing page for cognitive search. And again, there's not much we're going to look at here, but you'll obviously need some keys. So you go grab them, and there'll be an endpoint. But then we go to indexes. So this is like our tables. This is where we're going to land our particular data. And when we go into that, I'll ignore Search Explorer for now, but we get the fields. Now, I've just slung this together. It's not particularly scientific. So you'll see all of these are set to string, which is great. Apart from these ones at the bottom, which are vectors, they're slightly different, and I'll come to them in a minute. And then there's some settings over here for cores and scoring profiles, semantic configurations, vector profiles. We won't go into that too much. You will need to use them, but in the interest of time, I won't. But this works just like any database. So I can do new retail locations. And I've ingested that data that we saw there, the XYZ data, and we get a result from that. So we get some text, new store, expansion plans, and then we get a load of metadata, and then a load of vectors down here. But we might not necessarily want that. So in theory, we could switch to the JSON view, and this is kind of how you'll be interacting, but through the SDK. And we can remove some of that and make it look a little bit easier on the eye. So we have our content and scores and the original year and things like that. So that kind of grounds you, right? This is a simple database as far as that's concerned. But that vector blob that you saw there, that's where its power comes from. So go back to the slides. What are vectors? I am not a data scientist, so just a little bit of a caveat in that. But this is a way that you can use an AI model, essentially, to convert your unstructured data into a numerical representation that you can do some really complicated maths on. You create it using an embedding model. So you saw that ARDA embedding model earlier. In our particular case, that's what we'll be using. You store it in a vector database. Now, there are quite a few. AstraDB comes to mind that maybe DataStax could do. You can do it in SQL Server now, even in MySQL, for goodness sake. Interesting. But everybody is going to add this as a layer. OpenAI Search, Azure AI Search, rather, has been around for long enough that that was fundamental to what they've done. Other people are bolting it on. I'm sure it'll work fine. But I just chose this because it was an Azure service. But nonetheless, everything I'm saying here can be done with any LLM, and any vector database, it will just mean that you have to write your software differently. This allows you to compare two sets of vectors. It's actually quite complicated, so I've got 3 different ways of explaining that in the hope that one of them will land. So that is the actual top half, well, not even the top half, the top section of the vector representation of the word car. You do not need to read those numbers. That is the vector representation of the word lorry. Now, what we're doing is something called cosine analysis, and they're looking at the magnitude difference between each of those numbers to determine the similarity between them. I'm going to explain it a way that is not quite accurate, but at least conceptually will work. Imagine that top left number has wheels. Yeah? You could almost imagine that you could put these 2 things on top of each other, do that maths yourself, and figure out how similar they are. That is not how it's working, but essentially it is. That's how the cosine analysis is working. Some clever maths, very clever maths, and way cleverer than me. There is another way. Has anybody heard of the king-queen paradigm for this? Oh, nice. What a surprise. Do you want to come up and give this bit? So, if we take the vector for a king, so just like that car and lorry vector, it's just numbers, and then we take the vector for a man, and we subtract them mathematically, and then we add in the vector for a woman, what do you think we get? Answers on a postcard. You get a queen. And that is literally how this maths will let you run that. It's quite clever. So you have the king, and you subtract the man, and you're left with everything that is royalty, essentially, at that point. And you can then literally take the numbers for a woman and add them together, convert that back into the semantic meaning of what those numbers mean, and you will get a queen. It's quite clever, actually. But what we're doing here is figuring out the semantic similarity between 2 essentially non-connected items. Certainly when you start thinking about, if you had car, if you did a fuzzy search, you'd probably get cat, which is definitely not what you really want. You wouldn't get lorry. So important. Now, one final way of looking at this is a tensor board. A lot of this is explained in a computer file video. Has anybody heard of computer file, the YouTube channel? If you haven't watched it, it's very good. So they explain some of this, probably better than me because they're university lecturers, and I am not. This is a 3D space representation of a whole heap of IMDb reviews. You don't really need to be looking at what it's saying, but they're words and part words, because they're tokens, from a whole heap of IMDb reviews. So good, bad, negative, plain, whatever. If I scroll this across, and then what we can do is on the top right-hand side, we can search for a word. So if we search for a positive word, in this case, delight, we hit that. Now we get a clustering of words that are similar. So you can see they're all on this right-hand side of that 3D space. And if we start looking at some of these words, come on, zoom in, man. Then we get things like definitely, perfect, beautiful, heart, and things like that. Now, if we switch that word to something that's negative, then you can see conceptually what we're doing here. And remember, cosine analysis of magnitude difference, all of those words are now switched to that left-hand side of that 3D space. So they're grouped now. So these are the negative words, stupid, boring, poor, and words like that. So hopefully, with those 3 different explanations about how the maths is working, without actually talking about how the maths is working, you understand the importance of vectors. If you just used a regular database for this, it would be okay, but we are dealing with user prompts, and we want this to be natural language interaction, so we want the semantic meaning of the thing we're storing in there and not just the thing. So that's what that's telling us there. So with that, we can do a little bit more AI search. I wanted to show you about vectors first before I showed you that part of the app, because there is a section here at the top where I can switch between the different search modes. Now, if you remember, we can do a vector search. So this is the one I've just talked about here, the similarity. We can do a hybrid search. So we take the query as a full text search and the vector search results and give us an improved set of results. Then we've got the semantic hybrid search. Now, I've ingested data, as you're well aware, and I can do that same query again. I can't be bothered typing it, so I put it in my clipboard. So we will get some results if everything's working, good. I obviously did the right dance before this because the demo is currently working, so yeah, don't touch anything. Now, I'm not going to show you these for now because there's only 3 results and I can't really re-rank those to any particular value for you. They're just results. But the code for this, again, is not hard, and I'm not going to labor that. But we've got pretty much exactly the same sort of setup. So a bunch of Razor at the top, SignalR, and all we're doing on this page is receiving the cognitive search results. Yes, I know, I could have done it with an API. I don't need streaming, all of those things. It was already set up, and it has benefits later. And then we send that query, and then that goes out to the server. And then on the server, we've got some setup at the top here. It's interesting that nobody's taken a beer as well. Yeah, very studious. Impressive. I want a beer. Good. Yeah, I mean, do. Look, does it help if I have a beer as well? Ah, that's better. I feel better now. Good. Do. It's always good to have a little break as well. Hello. This bit's going to be fun in the YouTube video. The good thing is, it's certainly after work hours, so if your boss is watching, it's fine. Oh, there's only 2 left. Oh, no! Fight! I'm so sorry. Oh, I shouldn't have had this. I've deprived somebody. That's a red card in there now. No beer. Damn it. Right. I was saying, so you remember I showed you the keys and the endpoints and the index names. You'll need to configure that. I'll talk about some of this later, but what we're interested in is a single vector search, which is hiding down here. There's not much to it. Now, when you do, so you take the query that I'm going to go through this again in a minute, but don't worry. When you take the query, you need to create an embedded version of that. You need to compare those 2 vectors. So that's the first thing you need to do is use that order model and create a semantic meaning for that query. So, you know, what's the best cat GIF or something like that will have a semantic meaning. It will go off and then find cat GIFs and understand what that means. Yeah, the idea stands nonetheless. Then we have some search options here, and this is just a vectorized query and a simple one. Over here, we have got the select for that, so we're going to get the title, content, company, blah, blah. We can filter this as well, just like any good database. And then we perform the search. Now, there's a null here, and I'll come back to that. We get some search results. It's a blob of JSON, and I wanted a proper object, and so some really bad code here. But you know, if you've got a better way of doing this, great. But this is so that I could deliver it in a format that would work on the other side. So I create some objects, and then I have got some code here to filter based on the score. Now, you definitely want to do this, because a really low score is going to mean it's not quite sure whether or not this data is right. So you can have a cap, say anything less than 50% accuracy, don't even bother sending it as a result. You don't really want to influence the AI's response with bad data. So that's what that is. I'm not using it because there's not enough data in there to make it worthwhile. And in fact, when I did do it, there was next to no data. So I left it out. So I'm responding with the entire result set. Now, there's a hybrid search down here. Remember, vector search, and we can do a full text search on top of that. This isn't very dry, because that code is almost identical. But just up here, we're passing the query in. So that's the only difference. So where it was null, up here somewhere there, it is now passing the query in. So not too much with that. And then we can do that semantic hybrid search. And it's almost identical, apart from you have some settings for the semantic search. You'll need to have created the service for that. It's on a pay-as-you-go basis. It's not too expensive, but it still will cost you money, and the query type is now semantic, and everything after that is pretty much identical. Yes, I could have written this better, but it's demo software, so who cares? So that is the software for that. There's not much code to do that. I know there's a fair few lines, but there's not actually that much involved to get those 2 parts working. So, before we demo the full app, and how long have I got? Plenty of time. Let's look at what RAG is. So, we start with some sort of a front end, in my case, Blazor WASM, and an API on the back end. The API has got access to Azure AI Search and the OpenAI Service. In the beginning, you start off with your, in my case, PDFs, but your data. And there's loads of different ways of ingesting this, but in this particular application, we upload those PDFs. We then chunk them and send them to OpenAI for that embedded response. So that's that ARDA model again. So now we've got a bunch of their numbers, in boxes. We've got a bunch of them that we can store in our database now. So they're all those embedded parts. Now I layer on metadata, so the year and the document number and the paragraph of the document and things like that. They're useful for being able to refine those search results. Then at some point later, when your app's all up and running, you've ingested all your data, a user will come along and make a query. That query gets sent through the front end to the API. We need to create a vector from that API, from that query, that we can then issue to the Azure AI Service, and that will give us our plain text results back, as well as the vectors, should you want them. Then we take our original query, the plain text versions of both of these, combine them together into a single request, and send that all to OpenAI, and that will give you a response now based on your data. Do it with a database because you can update that. Of course, you could be arguing, well, why don't you just fine-tune your model? But if your data changes regularly, good luck, because now you have to fine-tune your model all the time. Not the best way. Do fine-tune your model, though, on things that don't change, so maybe coding standards that don't change very often and things like that, if it's where you're going to apply this. So do that. So the response comes back, and very importantly, you must return those results, because the human in the loop is real for all of this. It can make mistakes, and often does. So make sure that it's the human on the other side that is going to make the full interpretation and decide if that response is correct. So let's see what that looks like, shall we? So here's our app. So we're now essentially combining those two previous pages together. I can upload files here. We can do some filtering. Not much filtering, because there's not much data in there, but nonetheless, these are those facetable fields that I was talking about earlier, so you can ask it for those values and stick them in these boxes and use those for filtering. And you can choose between having a conversational style interface, or you can just do a single shot prompting. So in here, now we can do that same query of what was XYZ retail income in 2021. And look, now we get a response. And we get the sources on the right-hand side. And that is super important. So what I've done with my prompt engineering is I've told it to quote its sources so that we can then attach because this is a very simple demo. If you'd asked it to give you a lot more information, you would need to know where that information came from, and you could then attach it and make sure that you've done that. You can hover over this if your screen's big enough. I'm zoomed in. So that kind of gives you the idea from that. But what it doesn't have, if I do that again, is 2022's data. And it knows this. So we can see that response down there says, I don't have enough information to answer that. That's good, actually, because we've given it data. We've actually given it a bunch of 2021 data. So in this particular case, it has got it right. But this is relatively clear-cut. But semantically speaking, the number 2021 and the number 2022 are very close, if you were to do that maths. So that's the reason why we got it, plus there's nothing else in there. So let's give it some else. We're going to upload documents, and then we upload the 2022 stuff. This is one of the reasons why I like SignalR, because now, while I'm processing all of that in bits, remember, you upload it, you chunk it, you embed it, you store it in the database. If this is a big document and you've got lots of them, that process can take quite some time. I quite like that asynchronous UX that we get with that. You could do it with an API as well, I'm sure, but I've got it all working in SignalR, so why wouldn't I do that? If we refresh the page now in filters, yes, we've only got one company, but now we have 2 years, 2021 and 2022. So, in theory now, we can ask it about 2022, and we should get a result. There we are, and that's 100,000, and again, no smoke and mirrors, that's 100,000, just there. So now it is updated with the latest version of the data, and again, doing it like this, you can have an ingestion pattern that, say, once a day just goes and crawls through your SharePoint and ingests all of the latest data, sticks it in here, does all that embedding, and now it's live. If you did fine-tuning, it probably would be more complicated than that. And again, if your documents are big, if you do this with just the tick box portal ID, then you've not got any control over how that data's chunked. So some benefits here. But what's interesting, if the eagle-eyed people are watching here, I have got a 2021 result sitting there as the second item. Interestingly, this demo changed, as I mentioned to you. So I tested this last week, and there was no 2021 result in there. This week, now there is, and I can't tell you why. However, the demo still works, because if I go back to the AI search page, and instead of issuing that query, I had to come up with a different one to be able to illustrate my point. So at the moment, we're set with just that basic vector search. Don't need a question mark. So we get some results, but look, we've got 2021 as the second result. And in fact, when we scroll down, we've also, we've just got 2022, only one of them. So today, that is good, but it's still the second result. Now, if I switch to the hybrid search, full text plus vector, then it's still there. It's still the second result, so it's not ideal. But hopefully, because I've jinxed it now, saying that the demos are working, if I do the semantic search, so now this is running AI over the top of those search results and re-ranking them for us. Cross your fingers. Yes, look, see? So now 2022, 2022, 2022, and 2021 is the last result now. So although that's a pay-as-you-go service and you will be charged extra, this, carefully use my words here, reduces the amount of human effort required to be able to ensure that those results are correct. Again, couple that with a cutoff of your score at 50% or whatever you decide to choose, then hopefully those results will really satisfy the query and not give you some erroneous output. So, that is the app. To recap on that particular concept, because there was a fair amount in it, you probably got it, but nonetheless, we start with that front end and API. The API connects to Azure AI Search and OpenAI. We take our document, chunk it, embed it, and then each of those embeddings we can take and we can store one by one in our vector database. Then at some point later, when our application's all up and running, the user comes, makes a query, send it to the API, create the embedding, because we need to do that vector comparison, use your Azure AI Search service there, get the results back, combine it with the original prompt, send that to OpenAI. It will now inference over your own data, send that back, and again, can't stress this enough, send the results back as well so that you can compare them. Now, I am very proud because there is a, not just because the demos worked, there is, and because I brought beer, those things. I was involved in a project for the company I work for, Avanade, where we created the first ever intelligent garden at the Chelsea Flower Show, and that won gold this week. So that's pretty cool. Now, that uses RAG. That is a version of this. You can scan that QR code, should you wish, and you can talk to the trees in the garden that's live at Chelsea Flower Show at the moment. There are 12 trees sitting there, and 7 of them are instrumented. And each of those trees is different. They require different care. So we've grounded the data. We've stored it in Cosmos in this particular case, but nonetheless, the theory is the same. We ground it with what tree requires what requirements, and then you give it the data that you're reading live from the tree, take the original prompt, combine all that lot together, get the LLM to give you a response, and it will tell you in natural language what's up. This has been all over the news in the UK. It's been pretty cool. Quite like that. So I was involved in some of this piece. Actually, my part was creating an AI pollinator to detect little flying insects landing on flowers. That was pretty cool. And the Raspberry Pi, because I'm a huge geek. There is another really good example. The SSW stand have got something called the Yak Shaver, and that is another really good example of this, where you can take your bug reports and then ingest them into a system like this, and then make it so much easier for people to report how they found a bug. So that's cool. Now, I am not finished, because I mentioned earlier that I liked Clippy. Well, let me tell you. Clippy is not dead. I've built Clippy into this. Now, I like this, and that's in Clippy mode. So what is Microsoft's mission statement? Look! Oh my God. I actually quite like this as a paradigm, because Copilot takes up like a third of your whole screen. which is unnecessary for a lot of the stuff you actually want to do. I like this because I can drag Clippy down into the bottom right-hand corner, and I've still got my full screen. I think I want Clippy to come back. And I want Clippy to come back so much that I built one. Now, a crazy, mad scientist, ex-Microsoft guy, look, I don't know if you can see it, it's too far down, called David Pacman, and then his name alone is awesome. He created the 3D model and the design for this. I've just usurped all of the software, rewritten it in something called Uno platform. And, right now, this is why I've got this stool here. Don't kill Clippy. I had to make a box for this. I'll show you it in a minute. I'll turn this back on again. Now, this will listen. I can speak to it, and it will respond to me if it's working. Let's see, shall we? Right, so the first thing I need to do is actually start the software, because it's listening for a wake word, which is Clippy, or hey Clippy, and if I'd have done any of that, I would have spoiled the surprise now, wouldn't I? So, that looks like that's still okay. And in theory, we will get that traditional coloured prompt. So again, this is .NET 9 Uno platform. Has anyone used Uno? A couple of people. His eyebrows move. Hopefully somebody can zoom in on that and show. So this is connecting to that same SignalR endpoint. I've got authentication on that web app, by the way, so good luck trying to get in. Now it's listening for keywords. Hey, Clippy.
Okay, what would you like to chat about?
What was XYZ Retail's net income in 2021?
It looks like XYZ Retail Incorporated had a net income of $90,000 in 2021.
Do one, Alexa. I'm having Clippy. I love this. And again, I'm not going to take any credit for the design of the outside of that or the idea. That is David Pacman. That guy is awesome. Do go check him out. He's got his own robotics company. The guy is a legend. So I like that. So good. Right, that's the end of the surprises. So I promise there's no more other than you get a QR code. So there's some links here. Don't worry about those links. There's a QR code. The only thing that's not, I need to re-upload the slide deck because I changed it and added the link. So if you want that link to the Clippy, do take a note of that. Take a photo of the screen or whatever. I'll wait. You know, red cards if you go too fast. I'm hoping the beer offsets that. All the source code, you can go read that. The source code you see there right this very second is a little bit out of date. I've updated it. I will check it in, but I am not crazy. I am not doing that and updating my app before my talk. I will check all that in, so you'll get the latest version of that code. You'll find the Clippy source code on there in a separate branch, because I didn't want to spoil it for folks. The Azure OpenAI and AI Search services are great. There's an article there from Microsoft. Should you wish to go and learn a bit about retrieval augmented generation, it is very good. And I've been Pete Gallagher. Scan that QR code, we'll take you to the slides. Thank you very much.